In this video, we're going to talk about how to find the inverse of a function. The first thing that you have to do when you find the inverse is change f of x to y. In this case, it's already been changed, so we don't need to do that. The next step is to switch x and y. So this is now going to be x equals 4y minus 5. And then all you have to do is solve for y. So I need to add 5 to both sides. So I have x plus 5 equals 4y. Now we divide both sides by 4. So x plus 5 all over 4 equals y. Now since this is the inverse of a function, we have to change that back to f of x. But now it's going to be f to the negative 1 power of x. And so that tells us, oops, that should be a 4. That tells us that the inverse of this function is x plus 5 over 4. We'll do another one. Let's say we have f of x equals 2x over 5. Again, the first thing you have to do is change f of x to y. So y equals 2x over 5. Next, you switch x and y. So x equals 2y over 5. And now we have to get y by itself. To get y by itself, we need to get rid of this denominator here. And if you think about this, this is 2y divided by 5. So to undo that, we have to use the inverse of division, which is multiplication. So I'm going to multiply both sides by 5. So that'll become a 1. So now I have 5x equals 2y. Now I can divide by 2. So 5x over 2 is y. But again, we have the inverse, so we're going to switch that y into the f inverse of x. So that is your final answer. We'll practice some more here. Let's say we have one that's squared. So let's say we have f of x equals, actually let's do the square root of x plus 2. Again, we're going to change this to y. So y equals the square root of x plus 2.
Teacher, sorry for interruption. Mr. Miller sent out an email for witnesses seniors up here to meet with Johnston. If you would follow what Mr. Miller has said and go ahead and sit down according to time. Thank you.
Okay, now we'll switch x and y. So x equals the square root of y plus 2. And again, now we solve for y. If you look at this, though, that y is underneath the square root, so we have to get rid of that square root. The opposite, or the inverse of the square root, is to square. Notice I squared both sides, because what you do to one, you always have to do the other. So x squared equals y plus 2, because again, these are inverses. Now I can subtract the 2. So x squared minus 2 equals y. And of course, we have to change that back to f inverse of x. What if we have a problem that looks like this? X cubed minus 8. Do everything the exact same way. First, we're going to change f of x to y. So y equals x cubed minus 8. Then we'll switch x and y, and then we solve for y. So that's y cubed minus 8, so I need to add 8 to both sides here. So x plus 8 equals y cubed. Now that's cubed. Normally if we have y squared, we take the square root of it. So now that we have y cubed, we're going to take the cube root of it. So that's just a radical with a little 3 there. So now I have the cube root of x plus 8 equals y. And again, we have to change that to the inverse. So the cubed root of x plus 8 equals the inverse of f of x. Let's do one more for good measure. Let's say we have this type of function where f of x equals x plus 4 squared. Well, first thing we got to do again is change this to y. So we have y equals x plus 4 squared. Now we'll switch x and y. and then solve for y. Kind of like the radical function up here, where that y was trapped inside the square root there. Now we have y trapped into something that's squared. So the inverse of something that's squared is the square root. So we're going to take the square root of both sides. So I have the square root of x plus or minus, in this case now, equals, those will go away, equals y plus 4. Now we have to get y by itself, so I'm going to subtract 4 from both sides. So I have plus or minus the square root of x minus 4. Notice how that minus 4 is not inside that radical. The only thing inside that square root is the x there. Minus 4 is on the outside. That equals y. Again, we'll change that to f inverse of x.